Hello folks, and welcome to this lesson on secondary cells. By the end of this lesson, you should be able to deduce the reactions of the charging process from given electrode reactions for discharge and vice versa, and discuss the advantages and disadvantages of primary cells, secondary cells, and fuel cells. So first off, let's talk about what primary versus secondary cells are. So when you're thinking about cells and in the context of everything that I've given you so far, you're probably going to want to think of a battery, as in like the thing that you can put into other electronic devices to make it go. And yes, that is what a battery is. You either have two or more electrochemical cells, so each of those things with an anode and cathode, you have several of them hooked up into series, and usually that battery is going to be in a single container. Now from here, you might be aware of the fact that there are different types of batteries. Your very traditional type of battery where you use it all up and that's the end of it, and then you also have rechargeable batteries. So the first type of battery where you have the battery, you use it up, you have to dispose of it, that's a primary cell. And in a primary cell, the materials that you have, whether it's the anode itself or the electrolytes, they are consumed. They are used up, and that's why you can't keep on using it further. They are not rechargeable. You can't reverse that reaction to be able to continue using it. And then in your secondary cells, you have the reaction that will use them, but you can reverse those reactions to make back up what you have used. These reactions need energy to be reversed, and so that's why you have to plug them in to be able to charge them up. So probably one of the most well-known secondary cells that you are probably aware of is the lithium battery. The lithium battery contains lithium, of course, and the discharge reactions, so the reactions that produce electrical energy, the ones that make it the battery and it powers something else. At the anode, you have lithium metal becoming lithium ions and releasing that electron, and at the cathode, you form a complex between the lithium ion and cobalt oxide. Now, something that you may notice is the fact that we don't have any symbols for the state that the lithium ions is in. Well, the thing is that it can't be aqueous because of the fact that if you put water into these batteries, the lithium metal itself would react with the water, and so you would be left with none of it to react with it. Instead, this whole cell is suspended in a gel, and so that doesn't really fit in with any of the symbols that we use, so we're leaving that symbol-less. Now, as a result, our overall discharge reaction, so again, this is the reaction where you are releasing energy, or the cell is releasing energy, and you have lithium and your cobalt oxide forming a complex. So what's happening when we're recharging? Well, when you recharge, what you need is to make that lithium again, so that you have more lithium to react when you want it to discharge again. And so basically the charging reactions are going to be the opposite of your discharge reactions. So you take your lithium ions and you form them back into the metal, and you take the complex and split it up again. That's basically all this is. So as a result, the overall charging reaction is basically the opposite of, or the reverse of, the overall discharge reaction. That's all there really is to it when it comes to figuring out what the reactions are when you have the other set. We are going to talk about one more type of cell, and that's a fuel cell. And the fuel cells are interesting because of the fact that you're not set to having everything in the cell all having to be packaged beforehand and then have the cell go on. In your fuel cell, you continuously add fuel to it, and that fuel gets used up, and then you get your electrical energy that way. So for these fuel cells, all of them use some kind of fuel and oxygen. They're still using redox reactions, and electrical energy is going to be formed using them. Some of the different types of fuels that you can find are hydrogen, methanol, and ethanol. And as a result, all of them are going to produce water and heat. Some of them, the ones with methanol and ethanol, are going to also create carbon dioxide because at the end of the day, you need those carbons to go somewhere. So let's take the hydrogen fuel cell and take a look at that one as an example. So the thing is that you can take hydrogen, bring it into proximity with oxygen, add a little bit of energy, and then it goes poof and it explodes. Your teachers may have shown you this demo in the past in previous years. However, like I was explaining with the direct electron transfer versus indirect electron transfer reactions, that exploding of the hydrogen isn't going to help you when you want to create electricity. So you are going to divide that whole reaction into half reactions. At the anode, you're going to be using that hydrogen and forming ions, and then in the cathode, you're going to use those ions and oxygen to produce water. So there have been, or maybe there still are, I haven't actually looked into it, cars that use these fuel cells, and no, they're not actually burning them like a combustion engine would. They're taking advantage of these different half reactions and making the electrons flow, and that's how you get that electrical current to run the car. Now, the main components of a fuel cell are going to include the electrolyte or separator, which is a physical barrier for the half reactions, because again, if we have direct electron transfer, or not getting that flow of electrons to create the electricity. You're also going to have the electrodes, which are the site for the half reactions. And then you have a bipolar plate, which will conduct the electrical current and make sure that fuel is being distributed evenly throughout the whole cell. So to compare the three types of cells that we have looked at, your primary cells are not rechargeable. They are going to stop at some point because polarization is going to stop the reactions, or possibly the creation of hydrogen bubbles when everything is happening. Yes, you have a salt bridge, or you have some kind of porous membrane to help prevent polarization, but the thing is that at the end of the day, there is going to be a point where you also run out of things in the salt bridge, and it is going to be polarized, and so that's going to stop the reaction from happening. You can only use primary cells for low current devices as well. Secondary cells are rechargeable, but one of the issues with secondary cells is that self-discharge is more of an issue. So what do I mean by self-discharge? The thing about the secondary cells is that if you leave it alone, the half reactions can happen on their own without plugging it into something to connect everything together. And so if you leave a device that had been charged off for a long time, you might find when you turn it on again, the battery has gone down a bit. Well, this is because of that self-discharging issue that secondary cells can have. That being said, secondary cells can be used for devices that demand a little bit higher of a current. And then lastly, we have fuel cells. While they're not rechargeable, you can keep on using them for as long as you provide fuel. However, the issue with fuel cells is that the electrocatalysts themselves are expensive, and sometimes you can have issues with the storing of the fuel itself as well. Right, that's the end of this lesson. I'll see you next time.